Okay, so I wanted to go over your homework with you, and throughout this video, there will be some questions embedded, and you'll need to answer them. If you complete the video and answer the questions, you will get an extra credit point on your midterm. All right, so in number one, the main thing I want to point out is that it's important for you to um, first calculate everything in meters and seconds. So if you didn't do that, that went into points deducted from the units part of the rubric. And also note that displacement and velocity are vectors. So both of them should have the word west beside them or a negative beside them because they're vectors. So speed and distance, it doesn't matter what direction you're traveling in, but since displacement and velocity are vectors, then you need to make sure that you do that. In number two, you were to compare the average velocity to the average speed. Well, I told you the average speed was 180 miles per hour. I wasn't as concerned that you converted that to meters per second, but you probably should have because of the rubric. I didn't really take off of that, but I wanted you to recognize that the average velocity for one trip around the track would be zero because the displacement that you use to calculate velocity would be zero, and you needed to explain that. In number three, we had already done this problem in class, and so you really shouldn't have got these problems wrong, except for maybe the one we didn't do. So what I was really looking at was that you had an accurate dot diagram with 7 dots equally spaced and 3 dots getting closer, and then that you had a graph showing a increase in a constant velocity and then it rounding off to flat for the last 3 seconds. I did that in class for you. We found how far the car traveled over 7 seconds, which was just the constant speed times the time, 140 meters per second. And what I was really looking for was that you showed me your work in D. It's decelerating, so you need to use a kinematics equation, and the equation that you would use would give you a negative acceleration of 6.67 meters per second squared. Notice that I rounded at the 3 significant digits in its acceleration, so the units are meters per second squared. And in E, I did this one with you guys, or at least set it up. You wanted to find the distance that for the whole time. So the only thing you had to do was find the distance over 3 seconds using a kinematics equation because it's slowing down. You can't just multiply, speed times 3 seconds, and you can't find it over 7 seconds because you're not accelerating the whole time. You're just accelerating over 3 seconds. So, and I did this in class for you, and you just found that to be 30, and then you added it to 140, and the total was 170. And some of you guys, it's obvious that you found old answer sheets because I change my problems every year. So if you got like 160 meters, it's because you were using the answer for a previous, more than likely it was that you found an answer for the wrong problem. So be careful with that. Really? In number 4, some of you wanted to take 150 and multiply it by 10 to get the distance. The problem with that is that it is traveling at a constant velocity and then it's going to come to a stop. So it is no longer traveling at a constant velocity. So you have to use a kinematics equation, and you should have gotten 750 meters. And number 5, you needed to find the acceleration of the car, and most people did that okay. They did not round it to 3 sig digs, so it should have been 2.00 meters per second squared. And then they needed to discuss what the sign of the acceleration means. It's a positive sign, so that means that it would get faster in the positive direction. So if it's traveling in the positive direction, it's going to get faster in the positive direction. If it tries to go backwards, it will get slower. And in number 6, you had a dot diagram. And that dot diagram, you were going to answer some questions about it. So let me get it up here. So in number 6, The dots are getting closer, so it's in A, that's acceleration, and then the dots are equally spaced, so in B, that's constant velocity. The direction of the acceleration is always the direction that the dots get bigger in. Some of you said, right, that doesn't make sense. It's getting closer. So the reason it's getting closer is because the direction of the acceleration is to the left. If the car was traveling to the left, it would be moving and getting faster. But in this case, I told you the car was traveling to the right. So in D, the acceleration is to the left, but it's going to the right. So it is slowing down. In 7, you had to label the trajectory. So it had an initial speed of 200 meters per second. It had a speed of 0 at the top and a final velocity right before it hits the ground of negative 200 meters per second. So the problem is that you guys, some of you guys were telling me that the velocities were negative 9.8 meters per second squared. That is an acceleration. And a lot of you didn't even show me the velocities or tell me what the velocities were. It's really important in these types of problems that you understand the symmetry of the trajectory. We're getting ready to do projectiles where we have 2 directions of motion. But the y direction always looks like this. Whatever the upward speed is negative right before it hits the ground, but it comes to a stop at the top. So when you find how long it's in the air, you're going to evaluate from 200 to negative 200. And you should find that to be 40.8 seconds. Some of you just evaluated it to 0. You only found the time to get to the top. And then to find how high it rises, you only need to look at where it goes to the top. So you would evaluate it from VI at 200 and VF at 0. And I did these problems for you. So there really wasn't a mistake. There wasn't really a good reason for you not to get them wrong, except for the fact that I did a problem with a different initial speed. But the math is still the same. And then in number 8, I talked about this. Your initial speed is negative 20. So when you plug it into your kinematics equation, you're going to have to use the quadratic equation, and the correct choice would be 4.67 seconds. And then in B, you have to find the final velocity, and it's 65.7 meters per second. And I did take off for this, but really it should be negative, right? Because it's heading down. And then finally, your graph questions. So when you're looking at a position graph, slope is velocity. So it has a constant positive speed from 0 to 10, from 10 to 15, it's at rest, and from 15 to 40, it has a constant speed in the opposite direction. And the average velocity is literally the slope between those 2 points. You guys are trying to use a kinematics equation? You could, but you should be finding that as just a slope, which is negative 4.00 meters per second. And a lot of you just said negative 4, so that's a sig dig problem. Didn't add your sig digs. And then some of you didn't understand D. This was a multiple choice question. I just wanted you to pick the right definition. The definition of instantaneous velocity is the slope at every instant. You didn't have to calculate anything. You just had to tell me, choose the right one. When you look at a velocity graph, the slope is the acceleration and the displacement is the area under the curve. So in C, you had to tell me where it had constant acceleration, 0 to 2 and 10 to 12 seconds. And then you had to tell me where it had a constant speed, 2 to 10 and 12 to 16 seconds. And then finally, this is what most people missed, you had to find the displacement of the object between 4 and 16 seconds. So you needed to block off areas and find them. And this is really well illustrated here. It would be the area of the first rectangle, which would be 8 meters per second times 6 seconds. And then the second section has 2 shapes. It has a rectangle and a triangle. And the last one has a square. So you would want to just use your axes to find the lengths of those sides using your axis, not counting blocks or anything like that. And you should have gotten 76 meters from where it started.